Welcome to CUBE's webinar today. We're talking about building domain-specific enterprise agents with CUBE and LangChain. We have our speakers, Josh Patterson from Patterson Consulting, and then our in-house CUBE experts, Brian and Tony. Just a few quick notes before we get started. If you have any questions, you can ask us those in real time. Just simply enter your question, click submit, and we'll answer those during the Q&A portion. The recording of the webinar will be available on our events page right after the live event. And if you have any feedback, I would love to hear how we did. Tell us more about it. Simply email me at nathan@cube.dev. And so what we'll be discussing today, we'll learn what is CUBE, we'll learn what is LangChain, we'll also discuss knowledge versus reasoning in large language models. And then finally, we're gonna learn about connecting the enterprise data warehouse with LLM LangChain applications with CUBE semantic layer, and then end with a Q&A. So without further ado, I'll hand it off to Brian to get things started. Welcome, Brian.
Yeah, thanks, Nathan. Hey, everybody. My name is Brian Bickle, and I look after partnerships here at CUBE. And I've had the great privilege of working with Josh Patterson and knowing him for a couple years and seeing what Patterson's been up to. And I couldn't be more pleased to be on the stage presenting with him today. But before we get started and before we kind of kick over to Josh to teach us more about LLMs and LangChain, I do want to kind of go over CUBE and what we do here, and then I'll get out of the way quick enough and hand it over to him. Yeah, so if you aren't familiar with CUBE, and I suspect most of you are, but CUBE is a semantic layer product, and we bill ourselves as a universal semantic layer powering the next generation of data-driven applications by making cloud data accessible and consistent to every data consumer in the enterprise. And I do like to think of us, really focusing on application development and making data accessible and consistent, as kind of in the message there. For us, that is providing a layer of consistency and trust and validation over multiple data sources, and then making that available to kind of a growing body of downstream experiences, including these new emerging AI use cases. Traditionally, our two major use cases before have been embedded analytics, which is sort of where we got our start, and then connecting BI tools via our SQL API. And now, we're really expanding into this kind of growing AI area. And, the sort of, I guess, market that we find ourselves in and like why we built the product is this sort of growing many-to-many data chaos that we experienced as practitioners before coming to CUBE. I did anyway in my background, and that we've seen with our customers where, increasingly there's a lot of cloud data warehouses out there, relational database products, query engines, things like, exotic sort of time series databases. And as good as cloud data warehouses have become, we're not really any closer to a place where everybody's data is all in one location. So, data engineers juggling lots of different sources, I think is going to be, the situation going forward for a while. And then downstream consumers and users of data demanding access to that data in different experiences, whether that's embedded analytics via things like React or Angular or, various front-end frameworks, or traditional BI tools, like your Tableau preset, Metabase type things. And then, now we're starting to see a lot of adoption of tools like, OpenAI's LLM models. Specifically, our interaction with LangChain is something that we just shipped recently, and we're really proud of with our contribution to their repo. So really the the way we think about the semantic layer in terms of like where we center ourselves in the ecosystem is sort of adjacent to data sources, like your warehouse or your relational databases, as we mentioned, and then being a layer of consistency and trust and access control and empowering those applications that we just talked about. And here's a little bit more sort of detail on that if you want to understand how to center us in your mental model and like where we go. Yeah, it's the cube architecture diagram here. And to maybe click into exactly what Cube provides and what's in the box and how we think about semantic layers, we really center them on the four major pillars of the product that we provide, which are data modeling, access control, caching, and APIs. Cube's data modeling is delivered as a code-first experience, accessible and configurable in JavaScript, YAML, and manageable with SDLC best practices. You can check that code into Git and manage it there, version it, and do all your lifecycle activities. We also cover access control via deep role-based access control primitives and authentication via JWT and other methods. We do caching via our Cube Store, which is a proprietary query technology that we built to handle fast aggregations and caching of very high data volumes, so that we can provide improved performance over all these systems that we're querying from. And then everything leaves Cube as either a REST API, a GraphQL API, or our universal SQL API. The SQL API gives us connectivity to most BI tools right out of the box. And yeah, without further ado, having kind of told you a little bit about Cube and what we're doing over here, I want to set the stage for Josh and kick it over to him.
Thanks, Brian. A lot to jump around through today. So just really quickly, I run a solutions integrator called Patterson Consulting, and we work with Fortune 500 banks, insurance companies, telecoms, et cetera, and so forth. Previous lives worked in deep learning, and then also in Kubeflow as well. So really my tie into LLMs historically has been, I spent a lot of time building deep learning libraries and working with deep learning before transformers came along, a lot with LSTMs, and we actually wrote bots with LSTMs. Very simple, nothing like what we see today, transformers. And then in another phase, we did ML ops. And so that really informed a lot of what we're doing these days. So Patterson Consulting today, we have four major places, and obviously, LLM applications is a new thing. We have a background in deep learning, ML ops, but this is a specific blend of those technologies, as we'll talk about today. We also do data engineering, we do cloud DevOps, and we do managed platforms. So let's jump to it. What is a large language model? Many of you've probably used ChatGPT or heard of GPT, and OpenAI is really who busted this wide open, this market. And these models are trained on lots and lots of plain text data, and they learn patterns and structures. And then they can generate coherent, contextually relevant responses. And I had seen this before, honestly. With LSTMs, we wrote bots. It's like they could write reviews. They could do simple tasks. And so I really came into reintroducing, myself to this space skeptical. I was like, okay, they're not going to be that great. And I started using OpenAI, and I was like, not bad. And then we started exploring applications, and we progressively got more surprised. And billions of parameters apparently really help things work well, right? So as we explored that with our customers, we ran into LangChain. Now, there's several libraries out there, but today I'm going to focus on LangChain. It's very popular, and it's built around two key characteristics: data awareness. You want to be able to hook language models to data sources, and then focused around design concepts around agents, what we'll talk about a lot today. And you want agents to be able to reason about things. And that, as we'll see, that's not always just one inference call to an LLM. It's usually multiple or chains or if-thens around certain things that might happen. Further, LangChain provides a lot of components that you can build off of, like Legos, kind of snap them together, and then other use case specific chains. So let's jump into a demo real quick. I wanted to kind of go demo slide. The first demo I want to show off, let me switch screens here. Brian, check me to make sure that you guys see this correctly. Am I good? I'm good. All right. So kind of coming out of the gate, this is an agent. One customer we've talked to said, we just want a chatbot that integrates into, say, an existing application, and you talk to it like classic chatbots. And so they were like, we want to talk about cases. Potentially someone may be like, if you're working on cases and you're a worker and there's lots of information in the database, maybe they want to quickly in natural language say how many cases were processed in January 2023, right? And so this front end React style hits an API in our system, and we call our API system augmented reasoning. And I'll talk more about that in a minute. But it's right. And what that did under the hood is that went out, cranked up a LangChain SQL agent, and looked at the database and figured out what kind of value it should return. And there's several ways you can kind of parse up the data depending on the schema. Now, what's important here is the more you ask it questions with more facets to them, you can't hit just any database table. And we'll look at that more in a minute here. But it can be challenging if you have all your data in a data warehouse and the DBAs are cranky and they name things weird things, and LLMs want to speak plain English. You need an in-between layer, right? And so that's where data modeling really helps things work out. That's where you can take a table and create a view in Cube, and then hook the SQL agent to Cube, and the LLMs will perform a lot better. And the more that we notice that, the more we were like, yeah, this Cube really creates this nice layer. So let's flip back to the slides. And you see slides? We're good? Good. All right. So what makes these simple agents compelling, right? We showed an agent. You've probably seen a bunch of those. It's kind of OpenAI-ish, but it's still something you might see in a BI tool, but it's a chatbot. But it was not dealing with OpenAI knowledge or generalized training model, knowledge that would have been trained into the model itself. That was hitting a data warehouse. That actually hit Snowflake through Cube, and that was private data, just specific to that synthetic HR company, right? And I think another thing to kind of delineate here is when we were building demos early on, I talked to several companies and I showed them demos, and I said, I don't like to overmarket things. We don't, typically we don't throw the term AI around a lot. And if you look at my first book, Deep Learning with O'Reilly, we have a whole chapter on what is artificial intelligence, and we go all the way back to like the 40s and 50s and kind of look at different waves and the successes and the failures. And so we don't throw that term around, very lightly. So I talked to this executive and this team, and I said, "Is this really BI? Just tell me if it's BI." And they said, and basically, and they weren't looking at this demo; they're looking at some other demos. We'll show in a moment. They said, "Not by the traditional definition, Josh." I said, "Okay." I said, so we started kicking around terms. Well, what's different? And, with BI, you go out and it collects data for you based off a UI or a CLI tool or what have you. And then you do reason over that data. But in the LLM world, it can package reasoning with the data it collects. It can go and get private data, get public data, and then it can reason over that data. And that is a very subtle difference. And I like, even internally in our team, we did some demos and one guy was like, this is nothing new. We've seen this before. And I'm like, I don't know. There's something slightly different here. So we came up with a term called augmented reasoning. And, business concepts are semantically modeled for the agent. And the agent can reason about different ways to relate different business concepts. Agents can also make inferences about what intermediate concepts it needs to model to answer the question. So we're beginning to tease a more complex agent. That's what we're doing here. And I think the other thing here is, and this version of the slides doesn't have it, but I added a link at the last minute. Sorry, Nathan. We have an ebook on this topic, and you'll get it at the end of the slides. And it's on knowledge versus reasoning in LLMs, and talks about a lot of research that's been done. But what you want to think about with LLMs is they have two properties. They have some embedded knowledge, and they have the ability to do types of reasoning, logic puzzles, different things like that. They can write some code. Different models have different levels of reasoning. Different models have different types of knowledge baked in. But the thing is, if you try to use them as a database, you'll probably find that they'll hallucinate, say weird things a lot of times. So what you want to do, and the researcher Yao Fu says this, don't really use them for knowledge bases. Integrate them with knowledge repositories, such as your data warehouse, and then use them for their reasoning ability, and let agents use the knowledge plus the reasoning. Now, where Cube really shines here is it creates a semantic layer between the knowledge and reasoning, and allows you to give a better map to what's in the data warehouse. Because begin to think about these pieces of technology as like junior analysts. If you say, go pick up 2022's transaction list for December, the junior analyst looks at the tables, looks at the schema, and it's like, I don't know which table is right because they have all these weird names. But if you go into Cube and you name them very, very kind of plain English names, all of a sudden, the analyst is like, oh yeah, I can find that, right? And so that's what's really handy about Cube. We do that. So the keys to, just to hammer this point home, the keys to understanding LLMs and the semantic layer is LLMs provide reasoning, a knowledge repository, such as Snowflake, provides knowledge. The semantic layer, such as Cube, allows a pre-trained LLM to understand your knowledge repository in a way that can be relevant in reasoning answers to specific questions. Right? Traditional BI just pulls the data together and you do the reasoning. Augmented reasoning pulls the data together, and then maybe packages some further light reasoning. And ultimately, it's a knowledge work accelerator. And so what would this pattern look like? Kind of like on a wire diagram is this. You have a LangChain SQL agent. It's going to query the database via Cube. It's going to pull some context extracted. And sometimes it may make multiple passes to get all the context it wants out of the database. It may list tables, look at the names of the tables, look at the name of the columns, and it'll make this round trip several times, packages it into the prompt, sends the prompt over to the LLM, comes back, and then reasons whether it's got the answer or not. Now, single LangChain chain may just make a single pass. An agent will do a loop until it figures out what it really wants to know. So if we generalize this pattern further, you might have, in a more complex agent system, an agent that just looks at prompts and thinks about what that prompt might be talking about. Because if you try to pack too many instructions in a prompt, the agent will get confused and go in weird directions, right? And so it's like having a manager over multiple junior analysts and saying, okay, you specialize in getting coffee, and you specialize in SQL, and you specialize in data frames, right? And then you kind of figure out what the task is, and you hand it off to them. And then you can say, well, we can do more than databases. Our knowledge repository might be a website. It might be a vector database, et cetera, and so forth. And so we begin to expand the definition of what an agent is and how it can be built. Just want to note real quick, there's challenges with LLMs in integrating private knowledge, because when you start touching your data warehouse, you're touching probably customer records. And that data, as we just saw on the previous slide, gets sucked up into prompts. Those prompts get sent across the wire to LLMs. If you're using OpenAI, today, they don't really give you any guarantees whether or not that model, that data is not going to get sucked into their training engine, right? So you got to be careful there when you start testing with customer data or even go to production. And not many people are in production with a ton of LLM stuff yet, but it's something you really need to think about because it's, you know, a huge exposure. There are some early options. We offer on-prem models directly integrated, and we also offer a model serving service that gives you a GPU plus a private model. We'll talk more about that later. All right. So now let's look at, we're going to expand our knowledge a little bit more and look at just a common design pattern before we go towards a more complex application. So what if we said something that's not looking for something in a database? We said, what is a hurricane, right? And maybe the model doesn't have this concept already trained into it. Now, if you ask OpenAI, what is a hurricane, it'll give you an amazing answer. But let's say you had to decouple from OpenAI, right? And you were using a model that's, you know, OpenAI is probably over 100 billion parameters, which you probably are going to struggle to find a GPU with enough RAM on it to get that model into memory, which is a constraint. So if you were using a 7 billion parameter model and you didn't know what a hurricane was, what you could do was build a LangChain application, passes in the prompt through LangChain. The prompt analysis agent might say, well, this is a question answer. This is not, you know, database analytics. So it passes it up to that specific agent. And the question answer agent might go over to a vector database, which is where a whole lot of text documents are encoded into what's called an embedding, finds relevant document segments, pulls it into the prompt, and then sends the question plus the relevant sections of text to the LLM. And so you know, this is a method called, you know, you can give models context, and that's what it's always about. It's just a single, you know, models, LLMs don't have any memory of what you asked them before. You provide them like a historical conversation or some text records or what have you, and we're just you know, you package that in and you say, based on your knowledgeability, here's a question about this context, and this is what we would do here. And if we gave it some documents or a textbook about hurricanes, and it didn't know anything about hurricanes, it could reason its way and figure out that a hurricane is a type of tropical cyclone that is characterized by strong winds and heavy rain, right? So, all right, we've established some design patterns. We've hooked an agent to the data warehouse. We've looked at how we might build a, you know, a knowledge repository agent with a vector database. Let's look at maybe a different style agent, you know. So let's reintegrate these multiple types of agent systems into a more complex application that might feel more like a team member. So what if we asked a question like, what were the costliest hurricanes in 2018? Now, that is that could be answered by starting my demo system over here. That could be answered by a knowledge repository, but that's probably something better done with an analytical system, right? And so if that prompt comes in through LangChain, the prompt analysis agent says, we're going to go with SQL. We tell it, when you see these types of queries, we're going to answer this with SQL. Now, as we talked about before, I hinted about using Cube. That semantic layer really helps us talk to the data warehouse because our agents need very good plain English, and DBAs are not historically known for naming tables and columns with really good natural language English, right, or whatever your language. So if our LLM SQL agent is able to peer into the semantic layer, then it can see that I have a table, a view modeled called hurricane damage, costs, and deaths, and it's like, oh wow, this is really great information. It's all very, you know, and Cube does a really great job of letting you add more decorator description information, which they're exposing through their new LangChain plugins. And so the SQL agent then hooks back into Cube, talks to Snowflake, it's got the proper context. It looks at, it starts thinking, I need to list the tables. And then it sees we have power outages and we have hurricane damage, costs, and deaths. and it decides it wants to query the hurricane cost and deaths. And it makes several loops there. Yeah, sorry, this slightly different slide. Several loops there until it gets the answer. So I'm going to flip over and take a look at can you see the Hurricane Geospatial Analysis Workbench?
We can see it, Josh.
All right. Okay. So this is a little bit different system. This system is not just a chatbot for like specific application. We treat this system as if the CFO of the company is talking to it and doesn't know anything about hurricanes, but is very, very worried about how a hurricane can affect their company financially, right? And maybe they're like, here's the meteorologist talking in a meeting and he's like talking about hurricane season. Well, I don't really totally understand. I'm not a meteorologist by trade, but I know some. And so maybe they're sitting here and they're talking. There people are in their meeting and they start talking to their agent during the meeting, and they're like, well, "Define a hurricane season for me," right? And so the geospatial workbench comes alive, and under the hood, it's like, "Oh, this is general knowledge," right? It's hurricane season is a period of each year when the most tropical cyclones develop in the Atlantic Ocean. I'm like, okay, cool. I'm getting smarter, right? And then maybe I'm like, They start talking about the 2018 hurricane season being interesting. So I'm like, well, let's visualize. Now, if you tell OpenAI to visualize the any hurricane season, it's not going to give you that. And what do we do differently here? Everyone talks about programming. Everyone talks about chat. But if we're treating the system, just like a junior analyst, and you told a junior analyst, go build me a report on the 2018 hurricane season, and they went out and wrote their own mapping component, you'd get mad at them because they wasted time, right? You'd say, go use Folium or Google Maps or what have you. So what we did here is we built an agent that understands an API for a mapping system, and it's a custom API. So we gave it tools that weren't knowledge repository. We gave it a way to manipulate an interface, right? And so, I'm sitting here in this meeting and I'm getting pretty smart, even though, I'm not a meteorologist. And so this system can kind of react to what I want to, do. And Hurricane Michael, that was a big one, right? There's a lot of hurricanes that happen out here in the Atlantic, and we never hear about them because they just die out. So we want to flip around and we're like, okay, that's interesting, but what about if we want to know what were the costliest hurricanes in 2018? I don't want to click on all these, right? That's a different set of data set, but I'm going through a natural progression of how an executive might start querying the meteorologist, And the meteorologist is like, I don't have time for this, right? I got to go do important meteorologist stuff, right? I don't want to, but my junior analyst may not be trained to look that up. But our junior analyst hurricane agent knows where to look because it knew that this was a SQL analytic query. It went out through Cube, found the right databases, and queried them. It looked in there and said hurricane damage, costs, and deaths, just like we saw a minute ago, was where it needed to go. So what if we're like, Hurricane Michael's really interesting. This prompt is, so it's a little bit different than visualizing a season. We're beginning to drill down into. So it flips back into, I'm going to use the screen as a tool, and I'm going to show you a specific storm. And flip, I'm going to drive the API because I know it's a little different. I'm going to give you the information you want. And so now I'm like, oh, that's cool. That's very cool. I can come in here, see the county distance, see the path, see the Vmax gust, the Vmax sustain. Now, the agent didn't go write this, and the data is all in Cube, and some pieces are pre-cached in terms of precast views that come up, and it just says, give me this storm, or it uses an API call to get the data it needs for this map. It just has to figure out which storm it wants and what it should do in this scenario as a junior analyst, right? And so now we're beginning to separate ourselves from the concept of just a normal chatbot. Bots can do lots more, and I don't really actually think writing code and chatting is all that interesting. I think stuff like this is far more interesting, because then agents become, members of your team. And the meteorologist I showed this the first time was like, I thought he would pat me on the head and say, that's cute. And he's like, no, I like this because it makes me go faster. This is a knowledge work accelerator, right? So even more fun, he challenged me to say, well, I said, what do executives ask you? And I'm like, well, he's like, all the time there's depressions forming, and if they hit, what will happen to us? So let's, right now there's no depression. If you can tell the system there's a depression currently forming in the Atlantic, but there's not. I checked today. So I'm kind of at the mercy of the timing over at NOAA. But there is a depression, I know, forming in the Atlantic on 6/21. Tommy hurricane. That's a little bit different, right? There's something out there. Now, this is not something that would be in the database. This is something that might be forming right now. And on 6/21, Tropical Storm Brett started forming, right? So it went out to NOAA, as we'll see in a minute, and pulled in some text documents, decomposed them as embeddings in its local vector database. And Tropical Storm Brett started here. It had 40 miles per hour winds. That's where it currently was, 45. NOAA plotted some points out. Our agent didn't do that forecasting, but we just kind of make that part of the API. And the other thing the meteorologist says, he said, they always ask me, what is this similar to and what makes it unique? And he said, can you give me similar hurricanes? And so this is not really an agent thing, but this is just a math trick that we did. We created hurricane embeddings because we already had vector databases laying around. And every time you bring up a hurricane depression, historically, it can tell you different hurricanes that are similar to where it started and the vector it took. And then you kind of zoom out and you're like, hurricanes that tend to form in that cluster tend to curve out and not hit us. That's pretty interesting. The other thing it did, and it's on kind of on a rail, it's told to go pull the latest TWDAT file from NOAA, which you can see here. And I always tell it, show me your work. And these are the files it pulled. And it pulled all of this, analyzed it as a good junior analyst would, and then wrote this. So very dynamically, all of this analysis lets a meteorologist work faster. And it tells you, summarizes basically it's probably going to die out, right? These are the type of agents which are going to be embedded everywhere. These are the type of agents that are going to become table stakes in the next 3 years. These are the type of agents that you're going to integrate in every single one of your applications in some different way. And people are going to talk to applications. Natural language is going to become the DSL for everything. You're going to talk to the elevator. You're going to talk to your apps. So let's switch back and talk some more slides. And flip here, tell me if we get slides. And I'm gonna start a bonus query, and if we get to have time, I'll come back to it. We see slides, good. Okay, so what do we do and how do we build these things? Patterson Consulting, obviously, we do customized LangChain agent consulting. A lot of times people, I'm like, we'll say DevOps or what have you, and they're like, really just help us understand LangChain, understand llama index, maybe look at our LLM application architecture, look at our use case and compare it to, how does our use case relate to the hurricane agent? How does the hurricane, what could we use from the hurricane agent in our business? The other thing too is platform architecture, current custom agent design, custom knowledge repository integration. Can you help us use Cube to integrate Postgres, Snowflake, what have you? And we also offer private LLM model integration. All right. Since it worked, I'm going to flip. Well, I'll show it to you in a second. The other thing we offer is, and we're just announcing this week, is augmented reasoning.ai. So a lot of people are going to say, well, these agents are cool, but I don't have the infrastructure and the GPUs to run them. And we will help you design your agent and deploy it in the cloud, give you a secure endpoint, and just integrate it within your application to give you that custom chatbot that is connected to Cube and Snowflake or whatever you need, and then we'll scale it out, and then we'll get it. We will work with you to decide what class of reasoning you want. Do you want OpenAI? Do you want a private model system? And what type of GPUs you want? And so you could get, say, a custom application or like a pop-up window, and it would just be the chat window would hook to our API system at augmentedreasoning.ai. That may call out to OpenAI for its LLM reasoning, but for its knowledge integration, it would talk to Cube and then your database of choice. So I'm going to flip back over real quick because we're in the bonus and we've got time before questions. And I'm feeling froggy. And we landed the flip, Brian. Okay, can you guys see this?
Yeah, it looks great, Josh.
Okay, so there was one last query that I ran, and I love this one because what we did is the hurricane agent's still running, but it takes a minute for this to run because it has to really think about this. Now, all of the other queries were basic agents that did kind of one-off tasks. I asked it, if a Category 4 hurricane hit South Florida, and I misspelled Florida on accident, which kind of on purpose to show that it'll pick it up. The SQL actually wrote the correct SQL and corrected Florida, as you can see. How much property value will be lost? Now, what's unique about that comment? A, if you ask that to OpenAI, what happens? It's going to give you some generic answer, right? B, this is multi-step reasoning. Part of this is SQL. Part of this is how hurricanes affect property. Part of this is our portfolio. So you need multiple specialists working together. And so we have some next generation agents which do workflow planning. And then they have sub-agents who don't share all their context. They share enough with the next task agent. And so multiple pieces that first they figure out what they need to know, and then they go and tie into the agents that specialize in that specific task. And then the planning agent and the execution agent work together to get the complete query answered. So it thought about it, decided it needed to get the value of the property values from South Florida, from SQL, which connected to Cube, figured out what that, had, what is that, $10 million? Didn't format it pretty, but, and then it looked up in the table and determined the percentage of properties that will be impacted by Category 4 hurricane, 75%, is correct. And then it calculated the loss by multiplying the percentage of impacted properties by the total value of the properties. So we could potentially lose, is that what, 75 million? Need some commas in there. Need to teach the bot to put commas in there. But yeah, why is this interesting? This is extremely compelling because this is the type of question your CFO might ask during hurricane season. There's a million scenarios that can happen. These are non-trivial questions to go build. Agents like this can make your existing teams move faster, do more, and answer hard questions. Q&A. And while we talk Q&A, I'm going to leave up the resources. If you want 90 minutes of free LLM consulting, go to that link. We have a free ebook on large language models, and it goes really, really deep into knowledge versus reasoning. And you can always just reach out and talk to our experts.
Thanks, Josh. I really appreciate that. I've seen that demo probably 5 or 6 times now, and I still think it's interesting every time I see it. We do have one question so far in the Q&A, and I would encourage everybody to, if you have questions for Josh or for the Cube team, please get them in, and we will answer them as they come in. But yeah, the first one, Josh, is can you explain in more detail how the identification of each agent is determined based on the natural language query?
Yeah, so that's based around prompt routing. So there's really just one LLM call where you take the prompt and it comes in, and you give what is a prompt router in LangChain, the prompt plus 4 or 5 different, n number of choices, and it classifies the prompt. And it's not keyword matching. You can write it 10 different ways and it'll still pick it up. Now, sometimes the prompt router gets it wrong every once in a while. They get cranky sometimes. I don't know why. But yeah, most of the time the prompt router, if you write your prompt router prompt good, and you really describe how each prompt should be routed, you kind of do prompt engineering to do prompt engineering. Does that make sense?
Yeah, and could you talk a little bit about the domain that you focused on? I mean, I know that you demonstrated meteorological data in the hurricane demo, but what is your thinking, your process like for generalizing this to other domains?
It really is where you can find use cases that are typically very high touch. They involve some knowledge integration, but they're also maybe fill out a form, write a cover letter. They may have multiple steps. They may need a little bit of reasoning between the steps, whereas before an if-then workflow wouldn't quite be able to do it. With LLMs, they are able to, with some clever prompt engineering, you typically can reason your way through it. And you may, I don't know if I would completely leave the agents up to their own devices, and I'm pretty certain we won't touch anything that gives financial advice or deals with medical decisions. But your use cases need to be stuff that you can double check. You always want the agent to show their work, and sometimes you want the agent to this is my answer before we make actions or real decisions on it. Manually check it. So maybe they do 90% of the work, and then you bless it, or you tweak 1 or 2 little things, and then you hit go, right? And this is definitely not. In the ebook, I talk a lot about existential dread of people thinking this is going to take jobs, or you always get the person who shows up in the media and they say these sensationalized headlines around there won't be any radiologists in 3 years when deep learning came out. Now there won't be any programmers, and these people, and then they just poof disappear. They get their 3 minutes of fame. That's always terrible stuff. I hate it when people do that. I hate publications that play up to that. In the ebook, I talk about how you can look over the course of several hundred years, every time you get a new technology that affects labor in a very direct way. And the first example I call out is the textile loom in the 1800s. You got some people really mad thinking they're not going to have jobs anymore. And so they got behind this guy, and they created a movement called the Luddites, and they would storm into factories and burn looms, right? But what happened is the textile industry just changed. It adapted. Those people kept jobs, but they just produced lots more textiles, and then that changed, and that created new jobs and new industries downstream. And the thing, over the years has always been with automation. It was always the blue collar worker was the one affected, right? It was always us in the knowledge working class. We're like, yeah, that's your problem. You'll get used to it. But I've had a doctor call me recently, who knows, never talks about technology, and is like, what is this chat GPT? What's going on? And I could feel kind of like that tinge of existential questioning in their voice. When you can touch a nerve with the work, the knowledge worker class at that level, something has changed, right? And I think that what's new and interesting here is because we're accelerating the knowledge worker, that is affecting the workforce in a way that probably you haven't seen before, right? And that's gonna have its own set of ripples. And so we write a lot about that in the ebook. And there's by the way, there's a SSL issue with the PDF. Just it's fine. It's nothing wrong with it. Just something's wrong with the website. But yeah, I encourage you to take a look at the ebook. It's a lot of fun. It's got some cool paintings, impressionistic paintings done by Midjourney, which is another generative AI system. And all of the prompts for the paintings are about workers and existential dread and textiles, and so you see it starts aspirational, and then it goes very dark, and then at the end it kind of levels off in this plateau of introspection is what I would call it. So I really love the paintings. It's a lot of fun. All right, next question. Sorry.
Yeah, I actually really like the art in the book as well, so I think it's all pretty interesting. Yeah, another question we had is what LLMs can be hosted privately in case of data privacy constraints? So yeah, I mean, if you maybe want to talk about like how you've explored this and like which ones work well and which ones don't, and like what that process looks like. I do think a lot of people have data privacy concerns.
Yeah, and that's why we're already on that. I mean, our service for that is not, the wraps aren't off of it yet, but people are testing. It's called Reasoning Engine.ai. It's parallel to Augmented Reasoning.ai, and you basically can just say, I want Falcon, or I want, you basically have to rent a GPU with enough RAM for that size model to fit in memory. And then does it have enough reasoning horsepower? We're not really that interested in retraining models. We treat models, and this is how we're different from most companies. We treat models such as that we just want reasoning. We're going to hook them into knowledge and we just need enough reasoning horsepower to do your prompt engineering. And so we've developed what I call a prompt workout gym. And so you list like the prompts that your application needs, and then you run it against the specific model. You can run it against n different models with n different GPUs and get like a reasoning score, like how often it got the answer correct, and then the timings on the latency. So you might run like, a 20 billion parameter model on CPU, and it takes 15 seconds for each inference, right? And you're like, oh, well, it got the answers right, but it's too slow, right? And so you might say, well, I need to attach that to a better GPU. So we give you the ability to mix and match GPUs plus models and experiment to find the best one. Because you don't want to go and like get a 100 billion parameter model plus a DGX with 80 gigs of RAM, because those are super expensive. So we have some just-in-time methods to release GPUs and to give you, maybe you only want to have short bursts of, say, like a A100 chip with 80 gigs of RAM, and then you want to deallocate it. We can do that behind the scenes. We've managed GPUs on Kubernetes for a number of years, and so we have a team that's really built to do that.
Yeah, thanks, Josh. The next question I want to kick over to you. We had a person in the chat ask about just trying to understand exactly what Cube is doing here, and they said, am I understanding correctly that Cube is providing the context of the schema in the analytical use case only, instead of trying to obtain that context directly from the database?
So yeah, I mean, what if your table is named TXN _FF009? Because I've seen plenty of things like that, and like the LLM goes, I don't know what's in that table. But and then we build a view, we do some data modeling in Cube, and we might say, deaths and costs table. And so literally it's going to read the name of the table or the description. You have to have that plain natural language description somewhere, and most databases don't have that in there. And Cube very simply just give you that, like, what I call a glue layer, semantic layer, to glue your bot into your data warehouse.
Well, let's see what else we got. And just a reminder for everybody, we've got about 10 more minutes. So if you have more questions, go ahead and get them in here, and we'll subject Josh to them. We had a question about the hurricane agent that you showed. The viewer asked, how does it decide which is the best visualization format between chart, map, etc.?
Typically, like in the router will decide. It'll basically say, well, if we're looking at a hurricane season, we need to use this API. You need to use this agent, which this agent has the prompt engineering template to use this type of API in the map. So usually the prompt router sends it down over to an agent who specializes in just that mode. And earlier on, we had agents who had too many instructions, and it would just be sometimes it would go left when it should have gone right, and we just decided to kind of start using collections of agents as opposed to single agents with too many things. It's like giving your junior analyst a huge binder and expecting them to know all of it, and they're just confused and good at none of it, right? Let your agents be specialists and give them the tasks that they're good at.
Let's see. Got one more in here. What is the what was your process for loading the business domain data into a place where the AI agents can use it? I assume this question is more about maybe the vector DB side of things, or about the knowledge section that you were talking about obviously the warehouse.
Well, I mean, many times, if your business domain data is in your data warehouse, it's not going to move. So you just hook Cube to Snowflake or your data warehouse, and then you go. And that's kind of the nice thing, because most of the time you just, for security reasons, security teams are like, I don't want that moving I want that in one spot where I can watch it, right? And so it's not really loading. Now, if you have a whole bunch of text documents and you don't have any process around that, you might just have a directory full of PDFs, and then we use a preprocessor where we'll suck in the raw text documents, compute the embeddings, and then save the vector database file format. And then we just load that vector database at runtime.
We had a viewer ask, they said, we use a unified GraphQL schema for all of our data operations. Should we front Cube queries with GraphQL as well? Can LLMs understand, introspect our GraphQL schema? I'm actually interested in this question because I don't know how you're connecting to LangChain.
That's a great question, and I'm not sure. That would be one where I'd be like, call me and we'll try it. I mean, every time I go, when me and Brian first started dreaming of this demo, it wasn't anything like this, and we kept going, well, what if we did this? And then we kept calling people and going, what do you think about this? And they'd be like, well, add this. And like each time I was like, LLMs can do that. Like the mapping thing, I was like, can it drive a map? And then I was like, oh, it can learn APIs. It can learn it can spit out JSON and plug that into APIs. So I would be 95% sure that we can figure out a way to figure out your GraphQL schema. The trick is going to be prompt engineering, not model training. And I'm gonna throw this out there too. We've spent the past 20 years teaching people in the machine learning space that when you want to use a machine learning model, you need to retrain it on the distribution of your own data. And that was always the correct way. It took people a long time to figure that out. So when they come to LLMs, they always say, oh, well, we've got to retrain that model on our data. But if you treat the model just as a pure reasoning engine, and it already understands the distribution of natural language, and then you give it a knowledge repository with your specific knowledge, if it has enough reasoning, it can do what you want. So I don't really think you need to retrain that many models. Now there's going to be better models, right? But I would focus on reasoning and low-hanging fruit and just prompt engineering, right? There was one time, and that's that big long chain of that multi-step thing where I talked about hitting South Florida and how much part value we would lose. It kept like trying to round the number, and it kept messing up and breaking the workflow. And finally, in the prompt, I just went in there and I said, do not at any step try to round the number. And it stopped doing it. like literally in the prompts, you just give them really good prompts and they'll do what you ask them, but you talk to them like they're junior analysts. And yeah, prompt engineering is pretty magic.
Can you talk a little bit more about how, I guess, LangChain is actually interfacing with Cube? We had a question, and the viewer just asked, is the LLM generating the call for the Cube REST API or the SQL API?
It probably could do the REST API. Me and Tony looked at that at one point when we were prototyping, where it's writing SQL. It writes SQL, and it uses the Postgres SQL Alchemy database connector, and it knows SQL.
Yeah,
now it will write
the way that you
sometimes, but it knows SQL pretty well.
Yeah, and the way that our LangChain integration works is we have a semantic document loader that provides more context to LangChain, and then the way Josh is interacting with it is via the SQL Alchemy connector, right?
Mine, when we first started, they didn't have the plugin, so mine uses the old way, and I was like, hey, all this extra metadata here, we could suck this in. I mean, Tony were trying to figure out ways to pull that through the SQL API, and they couldn't do it, and so they very savvily said, here you go. We're just going to give you both. You know, so check out their LangChain component.
Okay. Yeah, let's see if we have any more questions. I think otherwise we'll.
One more, I think. Maybe. Can you provide an example of reinforcement learning use case to improve? So, not sure I understand. Yeah. Yeah, I don't know about that one. I'm not sure how to answer that one. I mean, I know what reinforcement learning is, and I think maybe they're saying, could you make this router smarter? Possibly. That might work, but I'm not sure. There again, much of the LLM landscape is here be dragons. You know, most of this demo, I was like, what if we could do that? Like the hurricane embeddings were done in like 12 hours over a weekend. Like I was like, let's do hurricane embeddings. That's not a real thing, but I know some time series trick, let's do it. And it worked, you know. So yeah, I think all those are great questions, and I think they're probably, if you have enough hacking time, you probably get it working, and I'm happy to riff with you about prompt engineering and how to do it. Ben Hickson asked, can it help me ask more interesting queries based on analyzing my data? You know, I've looked at that, Ben. I think EDA is going to get, like, I won't say EDA is going to go away, but I think you're going to have LLMs, and I think I think OpenAI has some stuff come out this week where, you know, you look at a data set and you just start saying, you know, analyze it for me. And what you do is just have a prompt, you know, an agent or multiple agents, like one agent might just say, I'm going to look at the outliers, right? And then another agent's going to say, I'm going to look at how the distributions look when we split based on dependent variable, right? And so, you know, one of the things that we do with like the Hurricane bot is like multiple agents do multiple tasks, and at the end they spit out their answer, and then a summarization agent takes each of the 3 or 4 answers and then reasons over those 3 or 4 answers and generates a final answer. And so yeah, I mean, we could build an agent that looks at 4 or 5 different things that we do in our EDA templates, and then at the very end gives you an EDA custom, a generated EDA report by a data set. So yeah, that's there again. I think chatbots and writing code are kind of the boring part of LLMs. I think stuff like this we're just having a lot more fun with it. Yeah.
All right, thank you so much, Josh. That was an amazing webinar. Thank you everyone for joining. If you have any questions, please reach out to us. You can also check out the resources linked on the platform. The recording will be available on demand using the same link that you use to register and watch this live program. And if you want to attend any more upcoming webinars, we do have another webinar on July 26th on getting started with Snowflake and Cube. All right, thanks everybody. Have a great day. Bye.